Good evening, everyone.
Good evening, sir.
How
Good
are you?
evening, sir. Fine, sir.
Good
How are
evening,
you, sir?
sir.
Little bit louder.
I'm fine,
Good
sir.
evening,
How are
sir.
you?
Yeah, fine, fine. Just hold on a second. We are almost at the end of the syllabus. Uh, Today we are going to start the new topic, human eye. See, human eye having the two components. One is the structure of the human eye, and the next one is natural consequences of colorful world, like natural consequences related to light. So we'll wait for it. What? I mean, just wait for a few minutes. If everyone joins, we will start our class. 6 members are there. Still, few members we are meeting. Once join, see most of the class today we are going to discuss with a video. The video in and around 29 minutes video it was. So before starting the class, I will explain again. It's completely animation. So we'll start the class within a few minutes. Anything wants to discuss, please let me know before others joins. How is going school, Hamsini? Pujita
Uh, nice only, sir.
is going.
Yeah.
Nice,
Completed the
sir.
whole physics.
No, sir. They are in light only, sir. Now only they have ma'am completed three ray diagrams for concave mirror.
Feeling easy. Second time.
Yeah, sir. Yeah, sir.
I will spend 2 3 classes. I will try to take one more extra class for practice of the light numericals completely. Uh, Maybe it will happen this Friday or Sunday, Saturday, not Sunday. Sunday I'm not going to take any class. Might be Saturday, might be. I'm expecting.
Sir, Nirupama will not be coming, sir.
What happened to her? Yesterday
Sir,
also.
some health issues, sir.
That's what I got a message yesterday.
Yeah, sir.
So meanwhile, we'll go to the objectives of this chapter checklist. So what are the things? Again, biology teacher will explain again for you people. I will tell you. Okay. So the same concept, biology teacher also will explain up to certain level. Second time, the same thing. Because generally in some schools we will split this topic into two parts. Yeah. Before going to starting the class, just what are the things we are going to learn in this topic? We'll see first. Yeah, this topic, human eye and the colorful world, natural consequences of light. Actually, we can say in other words, human eye and colorful world, natural consequences of colorful world. So, just simply you can call as human eye and colorful world. Yeah. So, what are the things we are going to discuss? First, we are going to discuss the human eye. The same that this human eye full will be explained a little bit elaboratively and in brief, whatever the thing, however you want, by biology teacher one more time. In this, we are going to discuss about structure of eye, structure of human eye and formation of an image that we'll see in this animation. Mainly, the biology teacher will explain about structure of human eye and defects in human eye. Formation of an image, how the image will form in human eye and how it will connect it to brain, the signals and everything you can see here. And the next one is terms, that some technical terms related to bio, terms related to human eye, cornea, retina, pupil, aqueous humor, crystal lens, muscles, certain definitions. It will be easy to explain using bio teacher that she will take care. And here we'll see video and we can make a note. Any doubts you can ask me. Terms related to human eye. When I'm playing the video, in between any doubt, please raise the thing. I will pause the video and I will discuss with you. Color of objects. This is the first topic of this chapter. The next one is defects. What are the general defects you can able to hear from your friends, maybe whoever is wearing the specs? Defects of vision and their corrections. Defects of vision and their corrections. Niranjan,
Sir,
what are the general defects you can able to hear in our friends or whenever they are using?
sir, some of them tell that they are not able to see the objects which are distant, sir, but they are able to see the objects which are nearby them, sir.
Long
And,
sight, short sight, correct?
yes, sir.
So these are here. The first one is myopia. Myopia. This is called near or short sight. The second one is called hypermetria. Far or long sight. Long sight. This is long sight we'll call as generally. We'll discuss each and everything, how the long sight will happen. If we understand formation of image, the corrections is very easy. No need to worry much about the defects. These are the main two things usually they will ask in examination, myopia and hypermetria. Next one is presbyopia. The fourth one is stigmatism, color blindness. 5 things are there. One is color blindness. Color blindness. See, again, up to here, the biology ma'am will explain again. So, but in this, the major and very much important is myopia and hypermetria. And in these cases, what kind of lens you have to use? That is the main. One more thing also you have to keep it in mind. Next one is numerical problems based on the defects of vision. Problems based on defects of vision that I will take at the end of the, like all the things. We will come back to mirrors problems and lens problems. After that, I will explain the problems based on the defects of eyes. Numerical problems based on the defects of vision. And after this, refraction and dispersion of prism, refraction and dispersion of light through prism. And So natural phenomena of diffraction, dispersion. So we are having very few natural phenomena applications that we will discuss. It is a general life what we are observing. The first one is a rainbow formation. First one is formation of rainbow. This is one of the natural phenomena we'll discuss related to dispersion of light. Rainbow formation, primary rainbow, secondary rainbow and all. The second one is refraction through the sky, or refraction of the atmospheric refraction. What will happen? What are the natural consequences if the refraction happen in atmosphere? Refraction due to atmosphere. And based on this, we will discuss why the sky was red color in sunrise and sunset and blue color in daytime. This will come. So after discussing with the scattering of light. Scattering of light. These are the things we are going to discuss. So all these things we will discuss with animations. There is no numericals in the natural phenomena, no numericals related to rainbow formation or any other things, only problems related to your defects of result. So shall I start the video? If anything you want to make a note, please let me know. So first, when in the beginning you have to see the different parts of the human eye, like a cornea, crystalline lens, iris, pupil and ciliary muscles. So we can start the video, guys.
Yes, sir.
Yeah.
Sir.
Once again, I will take the attendance and I will start the video. Yes, sir. 1 second, guys. We are also absent today. Jita. Okay. Sanjay Shivani. Tilak. Yeah. If you are unable to hear, please let me know.
Prerequisites. To start this chapter requires a firm understanding of the following. Basic properties of light, like rectilinear propagation of light, reflection, refraction, image formation by spherical mirrors, image formation by spherical lenses, know about some important terms in image formation.
Hope all are you clear with that prerequisite topics. Am I right?
Yes, sir.
Learning objectives. After completing this chapter, student will be able to have the knowledge on the human eye, understand the concept of power of accommodation, gain the knowledge and skill on finding defects of vision and their correction, understand the concept of refraction of light through a prism, gain the knowledge on dispersion of white light by a glass prism, recognize the part of light rays on atmospheric refraction and scattering of light. Introduction. What is refraction of light? How images are formed by lenses, and what are the nature, position, and relative size of those images? We can give the answers to above questions based on previous knowledge, which is studied in the chapter Light Reflection and Refraction. These ideas can help us to study of the human eye. 11.1. The human eye. The human eye is the most valuable and sensitive sense organ, and it is a natural optical instrument. The eye is nearly spherical in shape with a slight bulge in the front part, and it enables us to see the beautiful, colorful world around us. Let us discuss about the important parts of the eye and their functions. Cornea. The front part of the eye is covered by transparent spherical membrane called cornea.
Guys, if anybody wants, I will pause the video. Please make a note of different parts. Again, when Biomam is explaining these different parts and its what is its purpose in human body, you will be able to understand very clearly again. Please let me know.
Light enters the eye through cornea. Iris. Just behind the cornea is a dark-colored muscular diaphragm which has a small circular opening in the middle. Pupil. Pupil is a small circular opening of iris. The pupil appears black because no light is reflected from it. The dark center in the middle of the iris. The pupil determines how much light is let into the eye. It changes sizes to accommodate for the amount of light that is available. The iris regulates the light by adjusting the size of the pupil. Let us see how iris regulates and controls the amount of light entering the eye. When the intensity of light is more, or if it is a bright source of light, then the iris makes the pupil to contract, and as a result the amount of light entering the eye decreases. When the intensity of light is less, or if the light is dim, then the iris dilates the pupil so that more light can enter the eye. Eye lens. The eye lens is a concave lens made of a transparent jelly like proteinaceous material. The eye lens is hard at the middle and gradually becomes soft towards the outer edges. The eye lens is held in position by ciliary muscles. The ciliary muscles help in changing the curvature and focal length of the eye lens. Retina. The inner back surface of the eyeball is called retina. It is a semi-transparent membrane which is light sensitive and is equivalent to the screen of a camera. The light sensitive receptors of the retina are called rods and cones. When light falls on these receptors, they send electrical signals to the brain through the optic nerve. The space between the retina and eye lens is filled with another fluid called vitreous humor. Blind spot. It is a spot at which the optic nerve enters the eye and is insensitive to light, and hence the name. Let us discuss about accommodation of the eye.
Yes.
And
Before going to this, we will list out what are the structure of the eye. Important terms related to eye we can list out. Anybody can retain? They're just names. What is the first one?
Cornea.
Cornea. Second one,
Iris.
Iris.
iris. Third one, anyone?
Pupil.
Fourth one, ciliary muscle.
Ciliary muscles.
See, these ciliary muscles only will use the will change the actually in this is important. The glass is having a fixed focal length. Suppose if you are taking any glass, it is having fixed focal length, but eye is having a power. It will change the focal length according to the object distance. We can see very clearly a little bit far objects, and we can see the objects very nearer objects also. We can see like the muscles will exist. So which muscle? The muscles will contract and expand based on the distance of the object where you want what you want to see. Here, the ciliary muscles will place important role. So to which object you have to observe, the ciliary muscles will exist accordingly. That is the purpose of this one. The next one is crystalline lines. The sixth one is retina. This is also one of the important things you have to keep it in mind. The seventh, optics nerve. So through the nerves only, whatever the light falls on the retina, it will send the signals in the form of small kind of electrical signals to the brain. Sclera, SCLERA, and blind spot. Aqueous humor. And the next one is vitreous humor. So again, I am telling guys, I will request the biology ma'am to explain all these things. What is its function? What is its purpose in human eye? She will explain again. Is it clear, guys? This is the structure of the eye. If I want to, what kind of diagram you have to practice, I will show the diagram. Please practice the diagram. Yeah. You have to practice at least this kind of diagram, at least basic. This kind of diagram you have to practice. Black and white diagram. This is enough for us, for our level. You have to practice at least this kind of diagram, which will explain all the things: optical nerve, cilia, retina, cornea, ciliary muscles, aqueous humor, iris, and crystalline lens, and everything. You have to practice these kind of blind spot. Also will be you have to identify somewhere here it will be blind spot. So this diagram you have to practice to identify different parts, like different terms related to the human eye, structure of the human eye. Is it clear, guys? I can move to the next one. Anybody
Yes.
wants to make any note?
Yes, sir.
I can move to the next one. See, this about accommodation of eye means how the image forming in human eye. Here we will discuss.
Power of accommodation. Accommodation of the eye. The process by which the ciliary muscles change the focal length of an eye lens to focus distant or near objects clearly on the retina is called the accommodation of the eye. Power of accommodation. The ability of the eye to focus objects lying at different distances is called the power of accommodation of the eye. How does an eye focus objects at varying distances? When the ciliary muscles are relaxed, the eye lens becomes thin. Thus, its focal length increases and we see the distant objects clearly. When the ciliary
This diagram is important, guys. See, the object is here, the light is coming, and this eye will exist. See, I already explained how the ciliary muscle will exist by itself and it will accommodate. See, again, the image is forming exactly at the retina. So this, whatever the image is formed on the retina, it will convert into electrical signal. It will send to brain. So automatically you can able to view like what are the thing we are feeling, that is called vision we are calling as. Suppose if this refracted rays are not exactly forming the image on the retina, that is called defect. That we'll discuss in defects.
Muscles are contract, then the curvature of the eye lens increases and the eye lens becomes thick. Thus, its focal length decreases and we see the nearby objects. In brief, it is adjustment of the focal length of the eye lens which enables us to focus on objects situated at different distances. Least distance of distinct
And this is also important. Please make a note if you want.
vision. Near point. Near point or least distance of distinct vision is the point nearest to the eye at which an object is visible distinctly. For a normal eye, the least distance of distinct vision is about 25 centimeters. However, it varies with age of the person. For example, for infants, it is only 5 to 8 centimeter. The far point of the eye. Far point of the eye is the maximum distance up to which the normal eye can see things clearly. It is infinity for a normal eye. Cataract. The crystalline lens of people at old age becomes milky and cloudy. This condition is called cataract. This causes partial or complete loss of vision. It is possible to restore vision through a cataract surgery. Range of vision. The distance between the near point and the far point is called the range of vision. Defects of vision and their correction. The eye may gradually lose its power of accommodation. In such conditions, the person cannot see the objects distinctly and comfortably. The vision becomes blurred due to the refractive defects of the eye. There are mainly 3 common refractive defects of vision. These are 1. Myopia or nearsightedness, 2. Hypermetropia or farsightedness, and 3. Presbyopia. These defects can be corrected by 2 defects of vision. These are 1. Myopia or nearsightedness, 2. Hypermetropia or farsightedness, and 3. Presbyopia. These defects
Sorry
can
guys,
be corrected.
again please make a note. These defects, myopia and hypermetria, I will give the ray diagrams. What is a myopia and what is a hypermetria? So before going to this, we will see power of accommodation ray diagram. If it is a proper human eye, certain data we have to keep in mind. After that, I will give the defects of. See here, if it is a human eye, if it is a proper, no, there is no defect means the rays are coming from infinity distance or from wherever it should exactly form the image at this point. Even if it is nearer, the object is nearby here, so it will adjust the focal length in a different, and whatever the image is forming, it will form on the retina. Suppose if the image is forming here, like the rays are coming from here and image is forming here, so you can't see it properly. The image is coming from, because the image is not forming on the retina. Suppose even the image is forming here. So he can't see image properly. It's like a blurred image. So he can't see image properly. So this is called proper, like this is called defect type. This is also defect type. So how to adjust this lens? In this case, I have to keep a lens in such a way, it need to form the dotted line. It need to adjust the light rays, and here it need to bend the light rays, more refraction should happen. So that we will discuss in human. So here A healthy human, what is the least distance of the distinct vision? What is the minimum distance required to see an object very properly? At the age of 10, sorry guys,
So 25 centimeter.
there is a healthy and average person. But if I am taking the age point of view, 10 years, the healthy person means 18 centimeters. 20 years, it is 25 centimeter. And after 40 years, that's the reason they will keep a little bit far away from the eye and they will try to read. 60 years, 200 centimeter or above. So this is a listed distance. Between from 15 to 40, I can say 25 centimeter for a healthy person. So this is called least distant vision. That means this much of minimum distance is required to observe an object very clearly. Otherwise, if you are keeping less than 25 centimeter, your eye will become more strained. That's the reason below 10 years, if you are studying the things in a dull light, and if you are keeping the books very nearer to your eye, or if you are observing anything very nearer to your eye, it will become more strained. Automatically, you will get some kind of defects like eye strains and some other eye defects will arise. So this is a basic thing for a proper human eye. If there is any defects, that we will discuss here. Yeah, I'm going back to the video. Just see these defects. So here, see the ray diagrams. Nearsightedness, short sight. See this is a ray diagram for the short sight. This is a ray diagram for the long sight. So in the video he will discuss again. So make a note what is a myopia and what is hypermetria, how the ray diagram for the myopia and hypermetria, what kind of lens they will use for myopia and hypermetria, that is important for us.
Presbyopia. These defects can be corrected by the use of suitable spherical lenses. We discuss below these defects and their correction. Myopia. The light from a distant object arriving at the eye lens may get converged at a point in front of the retina in the vitreous body. This type of defect is called nearsightedness or myopia. Let us observe these cases, and then you can understand the concept myopia. In the case of normal eye, the light rays from the object fall on the eye and converge on the retina. In the case of myopic eye, the light rays from the object fall on the eye and focuses the light at a point in front of the retina in the vitreous body. The correction for myopia. To compensate this, we interpose a concave lens between the eye and the object, with the diverging effect desired to get the image focused on the retina. Hypermetropia. If the eye lens focuses the incoming light at a point behind the retina, this defect is called farsightedness or hypermetropia. Let us observe these cases, and then you can understand the concept. Hypermetropia. In the case of normal eye, the light rays from the object fall on the eye and converge on the retina. In the case of hypermetropic eye, the light rays from the object fall on the eye and focuses the incoming light at a point behind the retina. The correction for hypermetropic eye. A convergent lens is needed to compensate for the defect in vision.
Is it clear, guys? Myopia and hypermetria, what kind of lens you have to use, why you have to use that kind of lens?
Yes.
In case of myopia, you have to, image is forming in front of the retina. In case of hypermetria, image is forming backside of the retina. So to adjust this image formation distances, in case of myopia, you need more divergence. But in case of hypermetria, you need more convergence. So converging lens will be useful in hypermetria, divergence lens will be useful in myopia. So based on that, we can able to keep it in mind. And ray diagrams are very simple. We already saw, already I draw the ray diagrams also. So this is for myopia and this is my hypermetria. So this is another one. These three only measure presbyopia.
Presbyopia. What is presbyopia? Presbyopia is a common type of vision disorder that occurs at your age. It is often referred to as the aging eye condition. Presbyopia results in the inability to focus up close, a problem associated with refraction in the eye. How does presbyopia occur? Presbyopia happens naturally in people as they age. The eye is not able to focus light directly onto the retina due to the hardening of natural lens. Aging also affects muscle fibers around the lens, making it harder for the eye to focus on up-close objects. The ineffective lens causes light to focus behind the retina, causing poor vision for objects that are up close. When you are younger, the lens of the eye is soft and flexible, allowing the tiny muscles inside the eye to easily reshape the lens to focus on close and distant objects. Dispersion of white light.
Yes, is it clear so far? And what about astigmatism and color blindness? I will explain you separately. These three defects, is it clear?
Yes, sir.
Yes, sir.
The next one is, before going to this, before going to dispersion of prism, I am going to explain the remaining three more defects we are having. Then the fourth one is astigmatism. This is very rare eye defect. So this is, in these defects, I can't focus objects. I cannot focus objects both in horizontal and vertical lines clearly. Vertically. What is the reason this is? Vertical lines clearly. The main reason for this is causes of defects. The main reason is this defect arises due to imperfect shape of cornea or the lens or both. Imperfect shape of cornea or the lens or both. It's imperfect. So what is the remedy? What kind of lens I have to use here? This defect can be corrected by using a cylindrical lenses or refractive surgery. Using the cylindrical lenses or refractive surgery. Generally, these kind of things will happen in case of accidents and by birth some defects, maybe genes point of view, some defects will be raised. So astigmatism. We'll see anything is available related to astigmatism in our web. So this is, if the person is suffering with this kind of defect, they can see the images like this. Anybody felt images can look like this? Anyone? This will occur generally when I'm traveling in a bus. If I'm seeing the night time through the bus window, I can see the lights like this. Anybody felt like this?
Yes, sir. In car also, sir.
Sir, I
In
have
car
felt
also, if you see through the from the window, you can see that means that it's not refracting properly. It is dividing into different colors and it is forming the different images on the retina. Might be because of this reason, this kind of. But if it is occurring naturally, that is a defect in eye. See, this is the uh, astigmatism defect. How the mainly this is because of the shape. It is not properly shaped. See, irregular lens, and this is a regular lens. Our retina also, it's not a proper shape. Because of this defect will come. So for this, they will do the surgery or cylindrical lenses. They will use these kind of lenses to sort out this issue, like this defect. What is cylindrical eye defect? Here you can see. So this, they will use a cylindrical kind of lenses here. Is it clear, guys?
Yes, sir.
So they will use these kind of lenses. See here, normal vision, astigmatism. Once they kept the cylindrical kind of lens, they can correct the this defect. The next one is color blindness. What is the, anybody listen this term color blindness?
Yes, sir.
What is the color blindness? What, according to your point of view, we don't know much. Just we have to know what is the color blindness and what is the remedy for this. In this defect, the person can't differentiate or distinguish between certain colors. He can observe the colors, but particular colors he can't. He can see both are same. In this defect, the person or the human cannot distinguish between certain colors. We can't say any color. It is depends upon the person, certain colors. He can see blue color, but we may feel that is white. That kind of defect is called color defects. In such case, the person is said to be colorblind. This is called color blindness. See, this is a little bit in-depth concept. What is the causes? If you are roaming in a sun, if you suddenly enter in a dark room, what you can feel? How you will feel? You will be able to see properly? It will take some time to see properly.
yes.
Suppose you just played 1 hour or 1.5 hours in a sun, midday sun. It's very hot. And suddenly you entered in a room. It's a dark room, like a little bit dark room. What will happen? We won't see properly, correct?
Yes, sir.
So actually, when the outside light is more brightness and when the outside light is less brightness, we are having different two kinds of particles in human eye, that is called cones and cylinders. Cones and cylinders. So these cones and cylinders will adjust the light according to the brightness of the outside light. If the over brightness is there, it will adjust and we can see the objects clearly. If there is very less brightness, it will adjust automatically. You can see that. I will explain. 1 second, guys. Okay, 10 minutes. 10 minutes. Yeah, so these cones and cylinders are not, some cones are missing, then automatically color blindness will occur. This defect arises due to absence of cones with some specific colors. remedy. Because this defect is a genetically defect. It's a genetic defect. There is no remedy, no cure. It's not curable. The next one is cataract. How many people listen this one? Cataract operations. How many people listen this word? Generally, this kind of surgery will do for old people, like above 60, 70, that kind of people. It's a condition in which crystalline lens of eye becomes milky and cloudy due to some a thin or thick layer will form, a white color layer will form, which will which will hold the light falling on the retina. It will not allow properly the light inside the retina. So through the surgery, they will remove that layer. That is only the cataract. Generally, it will occur in aged people, 60 plus and 65 plus. They will do first for one eye and they will do second eye. If they are not doing this operation, they will lose the vision completely. So complete blindness will come. So to restore this vision, they will do cataract surgery. How many people know about the cataract surgery? Like, will listen, guys?
Sir, they will
I
use
have,
laser
sir.
lights. Sir.
Grandpa had done, sir.
Hmm?
Sir, my grandpa had done this. Sir.
Yeah, yes. They will keep. Eye will be closed with a black color spades at least for 20 days.
They
correct?
use laser, sir.
Yeah. Nowadays we are using laser, but still, if you go remote places like poor people, they will use the surgeries only. Surgeries only they will use. Even my father done the surgery only. Surgery in the sense they will keep a small hole using the like very small hole. It will like 1 mm or half mm hole. Through that they will pull that layer. And nowadays they are using the laser also. And they will keep one protective glass they will insert over the eye. So now defect of the eye, myopia. What is the treatment? Concave lens, hypermetropia, What lens we are using here? Convex lens. Suppose if I am asking the ray diagram for this is a human eye. This is a image formation. So by keeping concave lens, you can show like this. So the same as hypermetropia also you can draw. The next one is astigmatism. Cylindrical lens. The next one is presbyopia. They will use a bifocal lens or varifocal length. Varifocal length means variable focal length. Color blindness. There is no cure, not curable, because of it's a genetic problem. Incurable. Cataract. Cataract, only surgery. They will do surgery and they will replace a small lens. They will keep foldable lens. They will keep. So these are the overall human eye structure of the human eye, different terms related to human eye, defects of the human eye. But major is important is myopia and hypermetria. But you can learn if you want. If any doubts, we can discuss in the next class. Anything want to discuss overall all over this? Any kind of discussions need to require related to defects and everything. Even the same thing will be discussed by madam also again one more time. But technically, I will discuss, and the biological part of she will discuss. Any doubts, guys, from this?
No doubts, sir.
So the next one is refraction of light through prism. See this one. Refraction of light through prism means if a light passing through a prism, how it will refract. Generally, this we won't call as a refract, we will call as a deviation. It will change completely its path. That is only called refraction of the light through prism. It's called a deviation. And second one is dispersion of white light by a glass prism. So when a white light is passing through a prism, it will split into different colors. That is called dispersion. So refraction is bending of light when passing through a prism. Dispersion means splitting one white light into several colors is called dispersion. So we'll see first dispersion of the prism and see this video how the dispersion is happening. Why the dispersion is happening, we'll discuss after this.
By a glass prism of the eye is soft and flexible, allowing the tiny muscles inside the eye to easily reshape the lens to focus on close and distant objects. Dispersion of white light by a glass prism. You must have seen and appreciated the spectacular colors in a rainbow. How could the white light of the sun give us various colors of the rainbow? Before we take up this question, we shall first go back to the refraction of light through a prism. The inclined refraction surfaces of a glass prism show exciting phenomenon. Let us find it out through an activity. If a prism is placed in a room and a narrow beam of white light is allowed to fall on one of its refracting faces, what do you observe? It is found that light coming out from the other face of the prism is split to 7 colors. What are the 7 colors that you see on the screen? The various colors seen are violet, indigo, blue, green, yellow, orange, and red. This phenomenon, the splitting of light into its component colors, is called dispersion of light. The band of the colored components of a light beam is called its spectrum. Why does this happen? The acronym VIBGYOR will help us to remember the sequence of colors. We have seen that white light is dispersed into its 7 color components by prism. Why do we get these colors? Different colors of light bend through different angles with respect to the incident ray as they pass through a prism. The red light bends the least, while the violet the most. Thus, the rays of each color emerge along different paths and thus become distinct. It is the band of distinct colors that we see in a spectrum. Isaac Newton was the first to use a glass prism to obtain the spectrum of sunlight. He tried to split the colors of the spectrum of white light further by using another similar prism. However, he could not get any more colors. He then placed the second identical prism in an inverted position with respect to the first prism. This allowed all the colors of the spectrum to pass through the second prism. He found a beam of white light merging from the other side of the second prism. This observation gave Newton the idea that the sunlight is made up of 7 colors. Any light that gives a spectrum similar to that of sunlight is often referred to as white light. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of the sun. The water droplets act like small prisms. Atmospheric
Yes,
refraction.
we'll hold here and please refer what are the thing we completed today till dispersion of prism and refraction of the prism and dispersion of the prism and natural consequences over the dispersion of the prism we will discuss in the next class. Is it clear? Any doubts in this session? Please let me know, guys.
No doubt, sir.
No
It's
doubts.
clear now?
No doubt,
See,
sir.
it's actually interesting. Just you have to explore by yourself, like by seeing different videos or different articles from Wikipedia or somewhere. And you can, because textbook is not enough to understand this topic very clearly, I'm saying. It's just they will give the overview of this topic. It's like you can elaborate. It's like a general knowledge topic, how the rainbow is forming, why the sky is looking blue color, why the sky is looking red color in the evening and morning times, sunrise and sunset. All these things we can cover in this. So we'll meet in the next class. Bye, everyone.
Thank you.
Yeah.
Thank you, sir.
Any doubts, please let me know.
No doubt, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you.
Thank you.